the autoionization of water. There are other substances that autoionize, but water is an important substance and it is involved in a lot of our acid-base reactions. And so we have a particular discussion of it here. One water molecule can interact with another one to produce the hydronium ion and a hydroxide. So let's say that one of these hydrogens from this water will transfer to that one to make the result here. And if we want, we can write the equilibrium constant for this. That expression, the K for this, should be the products divided by the reactants, but in this case, both of our reactants are the solvent, or water, liquid water, so they don't go in the equilibrium constant expression. So this K is just simply the concentration of the hydronium ion, H3O+, and hydroxide, multiplied by hydroxide. And since this is such an important process, this K has a special name, KW. The W stands for water. And the value that we use all of the time for this is 1 times 10 to the minus 14. It is different values at different temperatures, but for the most part they don't vary that much from this value, and so it is adequate for our calculations. Now, you'll notice that if we were to start with just pure water, we should have an equal amount of hydroxide and hydronium ions, and this would be a neutral solution. So these two concentrations would be equal to each other. Now, we can also have an acidic solution where we have more H plus than we do hydroxide. And we can have a basic solution where we have more hydroxide than we have hydronium. These are the possible combinations and what each one of those means. Because the value of the equilibrium constant can vary a little bit with temperature, the concentrations of these at an equilibrium, or at a neutral, in a neutral solution could vary with temperature. In fact, they do. So just bear that in mind when we're looking at some of these finer points to this equilibrium.